Okay, section 1.5, problem 21. They give you a function here, f of x is equal to x squared minus 2x. They want us to determine a domain on which f inverse exists and then find a formula for f inverse for that domain of f. So the first thing to notice right here is that what we are dealing with, and I think you guys can see this right away, is an upwards opening parabola. I don't know the specifics yet, but I know that this is a parabola that opens up. And I can tell right away that a parabola opening upward is going to fail the horizontal line test, therefore it is not one-to-one. That means that its inverse, which I might try to quickly draw in green here, remember an inverse now would be symmetric with respect to the line y equals x, its inverse would be a sideways opening parabola, and that one would of course fail the vertical line test, meaning that the inverse of f as it currently exists would not be a function. They want us to make it a function. So, determine a domain on which f inverse exists. So what they basically want us to do here is limit the domain of the original function. Right now it's going to be all real numbers, but instead of the entire parabola, we really just want half of it. So I'm going to go ahead and try to graph this thing, and I wouldn't mind at all if you guys grabbed your calculators and just plugged that in. But real quickly, I'd probably graph this by factoring. If I pulled out an x, I end up with an x minus 2, and that tells me that this function equals 0 when x is 0, so right there, and also when x is equal to 2. Right over here. That means that its line of symmetry is right over here at x equals 1. So if I were to evaluate f of 1, that's actually going to get me the vertex of this function. That's going to be a 1 minus 2, which is negative 1. So 1, negative 1, right here, guys, is going to be the vertex of this original parabola. And so f of x is an upwards opening parabola that looks like this. And then, of course, on the left side, it does the exact same thing. Okay, so that is the graph of y equals f of x. Now, what they want here is a domain on which f inverse exists. And right now, this domain of all real numbers, f inverse wouldn't exist because of what we talked about over here. So this feels similar to what we did in some of the problems earlier here, like 8 through 15 on this homework assignment. We are basically going to cheat here, guys, and just erase the left half of this parabola. Because if we do that, if we limit the domain artificially here, then what happens now is that when we try to take the inverse of just what results right here, let's take a look at what that would look like. I'll do this in green. The blue parabola starts at the ordered pair 1, negative 1. The inverse of that then would be negative 1, positive 1. It would look something like this. Let's take a look. This point right over here was the point 2, 0. Now when I invert that, it's the point 0, 2. And now I'm hoping you guys can see what's going on right here. This green curve right here would be, let's see here, guys, the inverse of what we had initially there in blue. And because that blue function is now one-to-one when we limit its domain, its inverse, the green curve, is a function. So the limited domain here for which f inverse exists, this would be our answer here, guys. The original blue curve is only existing on a domain starting from 1 and going to infinity. It does include 1, but of course the infinity is always going to be a parenthesis. So that's going to be our domain right there. So determine a domain on which f inverse exists. Okay, got it right here. And then find a formula for f inverse in that domain. So let's get working on finding that formula. So here we go. We're taking this function right here, and we're going to find our inverse by switching x and y. So my y becomes an x, my x's become y's. Y squared minus 2y. And actually, this one's already in a great form here for solving for y by completing the square. Our a value here is 1, and our b value is even. I don't even have to move anything. This is awesome. So I'm going to take half of b, which is 1, square it, which is still 1, and add 1 here on the right, and I'll add 1 here on the left as well to balance that out. So my left side, I prefer that written as x plus 1. And on the right side, that is a perfect square trinomial that factors into y minus 1 quantity squared. We're trying to solve for y, so I'll do the square root of the right and the square root of the left. And when we switch sides here, we're going to get, I'll go up here, guys, we're going to get y minus 1 is equal to the square root of x plus 1. Now, I've talked about this before. Normally, we would put a plus or minus in front of that. However, we are only interested in the top half of this sideways parabola. By putting the minus there, that would actually include the bottom side, and now that sideways parabola is not a function, and f inverse doesn't exist. It also goes along, now, what we were talking about before about limiting the domain. So anyway, we're okay leaving the plus or minus off. And the last thing we have to do here is add the 1 to the other side. So here you go. Y, otherwise known as f inverse, is going to equal, that's going to be a 1 now, plus the square root of x plus 1, and that would be our answer here now, guys. That would be a formula for f inverse on that domain of f that was listed up here above. And remember, the domain of f is going to end up matching the range of y, and then vice versa. So that's number 21.